Good morning, students. Today we will discuss some problems of mains and advance on the chapter direction ratios and direction cosines. See, question number 1. If LMN are direction cosines of a line, then the maximum value of the product LMN. What is the product of LMN? These are the options. So we will solve this problem. Here LMN are given direction cosines of a line. Since LMN are direction cosines of a line, then we have L square plus M square plus N square is equal to 1. This is from the definition of direction cosines. So to find the maximum of these three numbers, I will use the concept for any number of numbers, their arithmetic mean is greater than or equal to geometric mean. I will take the three numbers. So arithmetic mean of L square comma M square comma N square greater than or equal to geometric mean of the same numbers L square comma M square comma N square. So what is arithmetic mean of these three numbers? L square plus M square plus N square divided by 3 greater than or equal to. What is geometric mean? There are three numbers. Therefore geometric mean of three numbers is cube root of product of numbers. L square plus M square plus N square. Since LMN are DCs, L square plus M square is 1. Therefore, this becomes 1 by 3 greater than or equal to. Cube root means it is whole power 1 by 3. Therefore, I can write this as LMN whole power 2 by 3. Now, I reverse this inequality. LMN whole power 2 by 3 will be less than or equal to 1 by 3. This implies LMN is less than or equal to. You transform this power onto right side. So 1 by 3 whole power 3 by 2. 1 by 3 whole power 3 by 2. So LMN is less than or equal to 1 power any finite number, it is 1 only. So 3 power 3 by 2. 3 power 3 by 2 can be written as 3 root 3. Therefore, this product LMN is equal to this or less than this. That means maximum value of LMN product is 1 divided by 3 root 3. These are the options. Therefore, second option. Question number 2. If direction cosines of a line are AB, B and the angle between the line and x-axis is pi by 3, then a possible pair of values of A and B. So to find A and B, here given that AB comma B are direction cosines of a line. Since they are direction cosines of a line, we know that sum of the squares is equals to 1. This is 1. Because if LMN are DCs of a line, then L square plus M square plus N square is 1. And given that angle between the given line and x-axis, that is angle made by the given line with x-axis. Always angle made by a line with x-axis is alpha, y-axis is beta, z-axis is gamma. That means here alpha is given. So what is alpha? Alpha is pi by 3. Angle made by the line with x-axis is pi by 360 degrees. Here AB comma B, they are DCs. DCs means they are values of cos alpha, cos beta, cos gamma. Therefore, what is cos alpha AB? Cos 60 is 1 by 2 is equal to AB. So in this question, to find a pair of possible values of AB, so we have to find two values. To find two values, we need two equations. There are two equations. From first equation, I will take A value. A is 1 by 2b. I will put this value here. A square, what is A square? 1 by 4b square into b square is there, and here b square plus b square is 2b square equals to 1. I can cut b square and b square. This implies 2b square is equal to 1 minus 1 by 4, that is 3 by 4. So b square is equal to 3 divided by 8. Therefore b value is, b is plus or minus root over 3 by 8. So he said a pair of possible values. It is a single answer type question, therefore only one option is there. So we need one value. So all the values are positive values, therefore I will take b is equal to root over 3 by 8. So I will put this value here. Then what is A? A is 1 divided by 2b. B is root 3 by 8. That can be root 3 divided by root 8. What is root 8? 2 root 2. I can cut 2 and 2. Then I will be having root 2 in the numerator. Therefore, it is root over 2 by 3. Therefore, a pair of possible values of AB are A is 2 by root over 2 by 3. B is root over 3 by 8. Therefore, the answer is first option. Next question, question number 3. Here three vertices of a triangle are given. The direction ratios of internal angle bisector of angle BAC. Okay, these are the options. I shall take the triangle. So this is the triangle, given triangle ABC. This is point A, this is B and this is C. This is internal angle BAC. This is angle bisector, internal angle bisector of BAC. Say this internal angle bisector is meeting the side BC at D. So already this A point is given. A point is minus 1 comma 2 comma minus 3, and B point is 5 comma 0 comma minus 6. C point is 0 comma 4 comma minus 1. To find the DRs of this internal angle bisector AD, already we have a point capital A on this line. If you know another point, then DRs can be found simply using x2 minus x1, y2 minus y1, z2 minus z1. Therefore, now I will try to find the point D. We know that this point capital D, it lies on the side BC and it divides BC in the ratio this is to this. This concept comes in center and its properties, its definitions. Therefore, I will find the length of this side. 5 minus into minus plus 1 whole square is 36. 0 minus 2 whole square is 4. Minus 6 minus into minus plus square is 9. What is this? This is 49. That means 7. I will also find the length of this side. Minus 1 plus 0 minus 1 whole square. 2 minus 4 minus 2 whole square. Minus 3 plus 1 minus 2 whole square, it is 4. What is this? This is 3. Therefore, The point D lies on the side BC and divides in the ratio 7:3 internally. Yes, we will find that point D. There is for a formula internal point of division. mx2 is 0 plus nx1 3 into 5 15 by m plus n is 10. Next my2 28 plus ny1 is 0 by m plus n is 10. mz2 minus 7 6 into minus 3 minus 18 divided by 10. Therefore, the point D coordinates are 15 divided by 10, 28 divided by 10 and minus 25 divided by 10. I can cut these by 5 with 5, but I am not simplifying because I want to find direction ratios. We need direction ratios of internal angle bisector AD. I have A as well as D. Using 2 points I can find the direction ratios. Direction ratios of internal angle bisector AD are. What are the internal angle bisectors DRs? It is a line joining D and A. So therefore x2 minus x1 15 by 10 minus into minus plus 1. Then y2 minus y1 28 by 10 minus 2. z2 minus z1 minus 25 by 10 minus into minus plus 3. Therefore, this is on simplification, this becomes 25 by 10. And what is this 28 minus 20? It is 8 by 10. And this is 5 divided by 10. These are the direction ratios or direction numbers, simply DRs. I said there are infinite DCs for a line. So any proportionate values can represent DRs of same line. So I obtained these numbers by watching options. So in all the three numbers, 10 is there in the denominator. I can cut 10 because proportionate values also represent DRs of same line. Therefore, the DRs of given line, this angle bisector are 2585. So therefore it is third option. Then next question number 4. If direction ratios of a line are 1 plus lambda, 1 minus lambda, 2 and it makes an angle 60 degrees with its y-axis, then what is lambda? These are the options. It is a question, more than one answer type question which comes in advance. See now. So a line is making angle beta with y-axis. So here given that the line is making angle 60 with y-axis. The angle beta is 60. Therefore, cos beta equal to. So these are what? They are DRs of this. See now, next question number 4. If DRs of a line are given and it makes an angle 60 degrees with y-axis. So angle made by a line with y-axis is given 60. That means it is beta. These are DRs. If you transform them into DCs, then they will be cos alpha, cos beta, cos gamma. We know how to transform DRs into DCs, dividing these three numbers by under root of a square plus b square plus c square. In that angle beta, angle made by the line with y-axis is given. Therefore, I will take cos beta. Here cos beta is 60. What is cos beta? L comma M comma N will be DCs, and they are also cos alpha, cos beta, cos gamma. That middle one will be the cos beta values. So if I write this 1 minus lambda divided by root over a square, 1 plus lambda whole square, 1 minus lambda whole square plus 4. So this is cos beta value. So what is cos 60? Cos 60 is 1 by 2. Squaring both sides and by cross multiplication. 1 plus lambda whole square plus 1 minus lambda whole square plus 4. So what is there on the left side? Cos 60 is 1 by 2. 2 becomes 4 and comes here. We are squaring no, therefore 1 minus lambda whole square. Let us simplify. A plus b whole square plus a minus b whole square. 2 into a square plus b square plus 4 is there is equal to 4 into. I will expand this. 1 minus 2 lambda plus lambda square. We will simplify this. 2 into lambda square. On the left side we have 2 lambda square. 2 into 1, 2. 2 plus 4 is 6. And here it is 4 minus 8 lambda plus 4 lambda square. Write all the terms on right side. This becomes minus. Therefore we will have 2 lambda square. There is only 1 lambda term. And the constant 6 becomes minus, it is minus 2 equal to 0. 2 can be taken common. Lambda square minus 4 lambda minus 1 equal to 0. So it is a quadratic equation in lambda. We will factorize this. So we will factorize this by using minus b plus or minus under root of b square minus 4ac by 2a. What is minus b? It is minus into minus plus. Plus or minus root over b square is 16 minus 4ac. 4 into 1 into minus 1. It is minus into minus plus 4 divided by 2. This can be simplified as 4 plus or minus root 20 is 2 root 5 whole divided by 2. So these 2 divides both, divide separately, then we will get 2 plus or minus root 5. Therefore, lambda values are 2 plus or minus root 5. See the options. Here 2 plus root 5. This is answer, and also 2 minus root 5. Therefore, answers are these two options. Yes. Please see next question. Question number 5. If alpha, beta, gamma are angles made by a line with positive axis, then what is this value? It is a numerical value type question. Alpha, beta, gamma are angles made by a line with axis. Therefore, cos alpha, cos beta, cos gamma will be DCs of that line. Therefore, we have cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is known. We have seen in concepts, right? Now to find the value of this, let us take this one. Cos square alpha plus cos of beta plus gamma into cos of beta minus gamma. So let us find this value. Cos square alpha. and I will take this second term, it is cos product. So I will multiply and divide with 2. Then what is this? 2 into cos of beta plus gamma into cos of beta minus gamma is equal to cos square alpha plus 1 by 2 into, yes, it is 2 cos A cos B. 2 cos A cos B is cos A plus B plus cos A minus B. Therefore, cos A plus B, sum of these two is 2 beta plus cos A minus B. This minus this, beta beta gets cancelled. We will have 2 gamma. Yes, further it is cos square alpha plus 1 by 2 into, I will use cos 2a rule. Cos 2 beta is 2 cos square beta minus 1, and it is also 2 cos square gamma minus 1. Yes, therefore cos square alpha plus, I will multiply with 2, 2 gets cancelled. We will have cos square beta. I shall take this term 1 by 2 into this. This is cos square gamma. And in the bracket constant term minus 1 minus 1 minus 2 is there. This 1 by 2 multiplies that also. Therefore, I will have 1. So since alpha, beta, gamma are angles made by a line with axis, we know cos square alpha plus cos square beta plus cos square gamma is 1. Therefore, this value is 1. So 1 minus 1, it is 0. Therefore, value of this is 0. It is a numerical type question. Answer is 0. Therefore, 0, 0, 0, 0.00. This is the answer. The next question, question number 6. If theta is the angle between two lines whose direction cosines are given by L1, M1, N1 and L2, M2, N2, then the DCs of their angle bisectors are, okay, firstly L1, M1, N1 and L2, M2, N2, they are DCs of a line. Therefore, they satisfy this condition. And also second one, L2, M2, M2, N2 also DCs. Therefore, sum of the squares is 1. And given that theta is angle between these two lines, when DCs are given angle between two lines theta, then we have cos theta. Cos theta equal to L1, L2 plus M1, M2 plus N1, N2. Yes, this is the given data. Now I shall take figure. What are DCs? DCs, LMN are DCs of a line, and this point is such that at a distance of 1 unit from origin. See Nana, I shall take a line now. Say this is OA, first line, and this is second line OB. DCs of this line are given. So this point is L1, M1, N1, and this point is L2, M2, N2. Right, for these two lines there will be two angle bisectors. For these two lines there will be two angle bisectors. This is one angle bisector and other side. This is also one angle bisector. Say the midpoint of AC. I will suppose midpoint of AC is C. Okay, midpoint of this is C. So since this line is angle bisector, this midpoint of A and B lies on angle bisector. So here OC is an angle bisector. Since C is midpoint of these two, I can write L1 plus L2 by 2, comma M1 plus M2 by 2, comma N1 plus N2 by 2. Okay, now we have O and C. O is origin, C is this point. We can write the DRs of angle bisectors. DRs of angle bisector OCR. When 2 points are there, what are the DCs? X2 minus X1, Y2 minus Y1, Z2 minus Z1. Therefore, L1 plus L2 by 2, comma M1 plus M2 by 2, N1 plus N2 by 2. These are what? DRs. That means direction ratios. But in the question, he asked direction cosines he asked. So when direction ratios are there, direction cosines of this angle bisector are. How to get direction cosines? Dividing direction ratios by under root of first one square plus second one square, third one square. That is OC distance. So I will write this as L1 plus L2 divided by 2 into OC distance. That is DC means unit vector, dividing that vector by its magnitude. Magnitude of this vector is distance between O and C. Similarly here also. M1 plus M2 divided by 2 into OC. N1 plus N2 divided by 2 into OC. So these are the DCs. To get the answer, we need to find OC value. Here I will calculate OC distance. OC distance means distance between O and C. X2 minus X1 whole square. That means I will have L1 plus L2 by 2 whole square by 2. 2 will be there, and M1 plus M2 whole square by 4, N1 plus N2 whole square by 4. So I will write 4 here because all the fractions have 4. On simplification, this is root over. These are a plus b whole squares. On expanding this, we will get L1 square plus M1 square N1 square, which is 1. Then L2 square M2 square N2 square, that is also 1. Then 2AB, 2BC, 2CA, that is 2 into L1 L2 plus 2 into M1 M2 plus 2 into N1 N2. 2 can be taken common. If you take 2 common, then you will have L1 L2 plus M1 M2 plus N1 N2. Since theta is angle between them, this value is cos theta. Therefore, I can write cos theta here. Divided by 4 is there. Yes, 1 plus 1, 2. I will take 2 common here. If I take 2 common, then I will have 1 plus cos theta. 1 plus cos theta is 2 cos square theta by 2. Divided by 4 is there. Now I can cut 4 and 4. Therefore, this is cos theta by 2. Therefore, DCs of OC angle bisector are L1 plus L2 divided by 2 into OC. What is OC? Cos theta by 2. Here also M1 plus M2 divided by 2 into OC is cos theta by 2. and n1 plus n2 divided by 2 into OC is cos theta by 2. These are the direction cosines of one angle bisector. See the options. It is here. Third option is answer. This question is more than one answer type question. Therefore, these are the two given lines. For two intersecting lines, there will be two angle bisectors. This is one angle bisector and this is another angle bisector, because these lines can be extended. These lines can be extended like this. So this is one angle bisector and this is another angle bisector. So this is also angle bisector. Therefore, there will be one more direction cosines. I will suppose this point is L1, L2, M2, N2, OB vector. At same distance, I will take another point, which is B dash. What will be B dash? Minus L2 minus M2 minus N2. And also I suppose midpoint of this AB dash is capital D. So D will be midpoint of these two, L1 minus L2 by 2, M1 minus M2 by 2 and N1 minus N2 by 2. Same process. Here I have find midpoint of AB, which is C. From this I have calculated direction ratios of angle bisector OC, then its direction cosines, direction ratios and direction cosines. Similarly, we will find the direction ratios of OD and then direction cosine. Right. Here other angle bisector is OD, no? Therefore, I will write DRs of OD. OD is second angle bisector. OD is a line joining origin and this point. When two points are given, DRs are x2 minus x1, y2 minus y1, z2 minus z1. Therefore, we will get this. M1 minus M2 by 2, comma, N1 minus N2 by 2. Yes, now we want DCs, no? Therefore, DCs of this angle bisector ODR. When DRs are given DCs, DRs are vectors and DCs are unit vectors. So dividing this by its magnitude is OD. Dividing this also. Yes, these will be the DCs. To get the answer, we need magnitude of this, that is OD. We will calculate OD distance. Distance between O and D. So this will be L1 minus L2 by 2 whole square plus M1 minus M2 by 2 whole square plus N1 minus N2 by 2 whole square. Yes. Let us simplify. This will be root over. So all the three numbers, they have same number in the denominator. On squaring, which becomes 4. Therefore, LCM is 4. So you expand the numerators. On expanding numerators, we will get L1 square, M1 square, N1 square, which is 1. Also, L2 square, M2 square, N2 square, it is also 1. Then there will be minus 2AB, minus 2BC, minus 2CA. Taking minus 2 common, we will have L1, L2 plus M1, M2 plus N1, N2, which is cos theta. Therefore, it is cos theta. By 4 is there. therefore root over. Here I will take 2 common. Taking 2 common, we will have 1 minus cos theta. 1 minus cos theta is 2 sin square theta by 2 divided by 4. 2 into 2 4 and this 4 gets cancelled. We will have under root of sin square theta, which can be sin theta by 2. So therefore the DCs of another angle bisector are L1 minus L2 by 2 into OD. OD is sin theta by 2. And M1 minus M2 divided by 2 into OD is again sin theta by 2. N1 minus N2 divided by 2 sin theta by 2. So these are the direction cosines of second angle bisectors. For every two lines there will be two angle bisectors. So this is there in the options, fourth option. Therefore answer is third option and fourth option. Right. Next question number 7. Any point on a line is given where r is any real number, that means r is a parameter. Then the direction ratios of the line, these are the options. So we know to find direction ratios, we need 2 points on the line. This is a general point on the line, therefore for different values of r, it will give us different points. You can put any value. I shall put r is equal to 0. If I put r is equal to 0, then this point becomes 1 comma minus 3 comma 4. We need another point, therefore put one more value. You can put any value. For example, we will put r is equal to 1. If you write r is equal to 1, then this will give us this point. 2. 1 minus 3 is minus 2. If you put r is equal to 1, this will be root 2 plus 4. Now these are the 2 points on the line. Therefore, drs can be found. When 2 points are given, what are the drs? x2 minus x1, y2 minus y1, minus into minus plus 3. Z2, this is Z2 minus Z1 is 4. Therefore, this is equal to 2 minus 1 is 1, minus 2 plus 3 is also 1, and this is what? Root 2. Therefore, these are the drs of the given line. Therefore, which option? Third option. Right. Next question number 8. If this and this are direction ratios of two lines, and LMN are direction cosines of a line perpendicular to both the given lines, then what is the sum of L plus M plus N? So here these are the drs of two given lines, and those are DCs of a line which is perpendicular to these two. So these are DCs. What are DCs? Basically they are drs only. So the third line is perpendicular to these two. If two lines are perpendicular to each other, then they satisfy the condition A1 A2 plus B1 B2 plus C1 C2 equal to 0. The third line is perpendicular to both the given two lines. Therefore, that satisfies this condition. So taking first line and that line, if I apply this, L1 L2 is L, M1 M2 is 2M, N1 N2 1 into N is N is equal to 0. That line is also perpendicular to this. If I apply the condition 1 minus 3m plus 2n equal to 0. So we have obtained two equations. So when you have two equations, you cannot find Lm and 3 values, but you can find their proportionate values. I will find their proportionate values. L divided by 4 minus into minus plus 3 is equal to minus m divided by 1 into 2 minus 1 into 1 is equal to n divided by 1 into minus 3 is minus 3 minus 2. Therefore, L divided by 7, m divided by minus 1 and n divided by minus 5. So these are the proportionate values of LMN. LMN are DCs, but their proportionate values are what? DRs. Therefore, DRs of the line which is perpendicular to given lines. DRs of the given line are 7 comma minus 1 comma minus 5. These are DRs. They are not the exact values of LMN. They are proportionate values. Therefore, they can be DCs, DRs. If they are DCs, sum of the square should be 1. But here sum of the square is not 1. They are proportionate values. Therefore, they are DCs of this line. But he said LMN are DCs of the line. So these are DRs. Now we will transform them to DCs. DCs of the line are. How to find DCs? There will be two DCs for each line. So I will find one DC. Listen, how to find that? 7 divided by a divided by under root of a square plus b square plus c square. 49 plus 150 plus 25, 75. Therefore, 7 divided by 75 minus 1 divided by root over 75 minus 5 divided by root over 75. These are DCs of the line. Therefore, they are LMN values. For every line there will be two DCs. If these are one triad of DCs, then what is other? By changing sign, minus plus minus. No problem. Always you find only one DC. If you write one DC, other DC will be obtained by changing the signs. Here in the question what he asked, what is the sum of L plus M plus N? We will add these three. Their denominators are equal. Therefore, take LCM. LCM is root 75. Then in the numerator, we will get 7 minus 1 minus 5. What is that? It is 1. 1 divided by root 75. Root 75 is 5 root 3. So, there will be another pair of DCs. Therefore, you can add plus or minus here. Plus or minus 1 divided by 5 divided by root 3, because in the options two different values are given. Therefore, L plus M plus N is plus or minus 1 divided by 5 root 3 means second option. Please.